Hi everyone. Tonight's video is going to be a brief introduction to three-dimensional shapes. And basically the three-dimensional shapes we're going to be talking about are similar to the polygons that we've already been working with, but we're going to add a little bit of depth to them. So what we're used to is working on something flat, right? Drawing something on a piece of paper or on the coordinate plane that's just made up of the x and y axis. And so that's two-dimensional space. Right, we're just thinking of these different polygons that we've been drawing. But now what we want to do is start to add some depth to them. And when we talk about adding depth, and we're trying to still picture like a coordinate system, we would have what's called the z-axis. The z-axis is like this third dimension. And this isn't too hard to visualize because we live in three-dimensional space. So everything that we see, we're used to having some sort of depth. It's just a matter of it being a little more difficult when we're trying to draw it on a piece of paper. So here, for example, is an x, y, and z coordinate system. So the x-axis and the y-axis we're pretty used to. So here's the positive end of the x-axis. This would be the negative end of the x-axis. This would be the positive side of the y, and this would be the negative side of the y-axis. But now we've thrown in this third axis here, and this is what's called the z-axis. The way that you're going to think of this is that when the line is moving forward here, it's like it's coming off of the page at you. And this line that's going back is the negative z-axis, and it's like it's going through to the back side of the page. And so when we're thinking of images like this, when we see like this angle or something that's drawn in this direction, we're thinking of that as going back. And you may have like doodled or drawn things in your notebooks that are three-dimensional and not even known it. So if we were to take any one of our pentagon, polygon, heptagon, whatever shape that we want to take, we can make it three-dimensional. So if we're used to drawing, let's just draw like a square here. And if I want to make this three-dimensional and give it some depth going back, I'm just going to draw a line from each vertex or each corner going back diagonally. So if I just take that and I'm just consistent and I start at this corner, then I'm going to go to this vertex and draw a line of about the same depth back. Same thing here. It looks like the same line each time. And now I connect them. I've gone from having just a plain square to a cube, right? So now this looks like it has some depth to it. So this is what we're going to be doing. We're going to be taking our two-dimensional shapes that we're used to working with, and now we're going to start adding some depth to them. So if we do that, here's an example of a 3D pentagon. So we have a three-dimensional shape version of the polygon that we're used to working with. And so when we're working with these different shapes, we're going to want to identify three different types of parts. So there's the faces of the polygon, and the faces are the different sides. Okay, each side of the shape is called a face. And with the ones that we're working with, we're going to be using just the sides that are polygons. So all faces are going to be polygons with this. And I'll explain a little bit more about that in a second. Edges of the three-dimensional shapes are all going to be line segments. So there are all these different parts here that you see, the different line segments that are connecting the different sides of the faces. And the edges connect from vertex to vertex. So the vertices are all these points along the edges of three-dimensional shape. Okay, and sometimes what you'll see when these shapes are drawn is, so it's clear this front side is a pentagon, here's another side, it's like a rectangle, there's a pentagon on the back, and then there's other sides and edges that connect them. So sometimes what you'll see is dotted lines to fill in what's supposed to be the sides that you can't quite see. So if this pentagonal prism was made of glass, you would see edges connecting all these vertices on the other sides. So what you'll see sometimes when people are drawing these, you'll see some dotted lines to kind of help you visualize what's going on the other side there. Okay, but each one of these parts are identifiable, right? So we can have names for all of these. So just like we would name a pentagon in two-dimensional shapes with the different vertices A, B, C, D, and E, we can also do that for these three-dimensional shapes. But we also don't want to forget that there's all these other vertices on the other sides that maybe we just can't see or visualize when we're looking at it from the front. So the vertices of this are A, B, C, D, E, F, G, H, I, J. So there's 10 vertices for this shape here. The edges are all the line segments that connect them. So A, B, B, C, C, D, D, E, and E, A make up that front face. F, G, G, H, H, I, J, and J, F are all the edges of the back pentagon. And don't forget that these are all edges too. So E, F, D, G, C, H, B, I, and A, J are all edges of this prism. And then the faces are all these different shapes. So there's A, B, C, D, E makes up the front face, that's the pentagon. F, G, H, I, J makes up the back face, that's a pentagon. But then there's these 5 other faces, or panels, if you want to think of them, to this shape. So E, F, G, D is one. D, G, H, C is another. It's a rectangle. It makes up that panel. C, H, I, B is the panel on the bottom. A, J, I, B is this panel here. And E, F, J, A is that panel there. So we can identify many parts to this three-dimensional shape. Now, when we're talking about these three-dimensional shapes, we're actually specifically talking about something called polyhedron. And polyhedron are 3D shapes that are made up of faces that are all polygons. So all the polygons, or all the shapes we're going to be working with, are polyhedron, meaning that they're made up of polygons. So the sides are going to be rectangles, triangles, pentagons, that sort of thing. And there's a few different classifications of polyhedron. First, what we're going to be working with the most, and what I've shown you so far, are what's called prisms. And prisms are polyhedron where they have a set of parallel faces that are congruent shapes. So if you look at this shape here, there's these 2 faces that are triangles, this back one and this front one, and they are both congruent. They're the same size and shape. And so this is what we would call a triangular prism. Okay, so the prism is named by the shape that is what we would call the base of the prism. So the base is what identifies this prism. It's the 2 shapes that are congruent, front and back usually, or top and bottom, sort of could be the orientation here. And that's what makes up a prism. So in the previous example, that was a pentagonal prism. This here is a triangular prism. And they can be, the bases could be the front and the back, or they could be at the top and the bottom. But they're the 2 that are congruent shapes. So don't be confused and call that the base. That's the bottom of the triangular prism. But when we're talking about the base of a prism, it's the 2 shapes that are congruent. The other type of polyhedron that we're going to talk about are the platonic solids. And these are really neat, and we're going to work on these in class. We're going to talk about them a little bit more. But if you want to see diagrams of them, they're on page 61 in your book. And there's only 5 platonic solids, and that's because they're polyhedron where all the faces are the same regular polygon. And there's only 5 that you can make because there's certain limitations in how they can be connected, but they are the same regular polygon. So remember, a regular polygon means the sides and angles are all congruent in the shape. So like a equilateral triangle or a square, or a regular pentagon is a 5-sided polygon where all 5 sides are the same length and those angles are all the same. Okay, so there's other regular polygons, but there's only 5 ways where you can make a 3-dimensional shape where every face is the same regular polygon. So like I said, we'll talk about that later. And then the last special category of polyhedrons that we're going to talk about are pyramids. And we are pretty used to seeing pyramids in our history books, or usually it's one of the first 3-dimensional shapes people think of. But a pyramid is kind of like a prism, but instead of having a congruent shape or a congruent face on the other side, it's like somebody took that off and then all the sides collapsed into this one point. So a pyramid has basically one common vertex at one end and then a polygon base on the other. So this would be called a pentagonal pyramid. And that's because the base of this pyramid is a pentagon, right? So if we look at the bottom here, and that's where you can see those dotted lines a little bit in the background, that makes a pentagon on the base. And then at the top, instead of having another congruent pentagon to make this a prism, there's just a little point where, or a vertex, where all the other sides come together. Okay, last thing we'll mention, there's some other 3D shapes that are not polyhedron. We'll talk about them, we'll introduce them now, but we'll talk about them much more later in the year. They're not polyhedron because their sides are not polygons, right? So these are all circular. So a cone is kind of like a pyramid with a circle base. A cylinder is like a prism with a circle bases. And then a sphere is almost like a platonic solid with a circle in the middle for your to give you the depth, the circumference, or the circle crosscut there is what we would refer to that as. So this is like a ball, this is like a can, this is like an ice cream cone. So we're all familiar with that stuff. So on your own, draw and label 3 different polyhedron, including at least 1 prism and 1 pyramid. Make sure you identify each side, edge, and vertex. So basically all we really want you to do is get some practice drawing these. So pick a polygon, it can be any shape. So we can try to draw a triangle here, and you could just sketch these. So first thing, you start with a polygon of whatever shape you'd like, and then when we want to add some depth to it, remember we draw a diagonal line back, and we're going to do that from each of the vertices. And here, if that's the inside, you can draw with like a dotted line if you want. Okay, and then connect this side here. So this is just a rough sketch, and then you can label all these parts with some vertices. And so just get some practice doing that. Draw at least 3 of them. You can be creative and come up with some different colors, that sort of thing. So bring at least 3 examples with you to class tomorrow. And I will see you then. Have a great night.